Solving logs by rewriting it in exponential form. This is the quiz trade type method that we practiced when we first talked about what the logarithm is. When we look at the log, the first thing we need to ask ourselves is that 6 inside the log? If it is, it stays and then we rewrite it. If it's not, we move it before we rewrite it. And this is not inside the parentheses like it is in the second problem and the third problem. So we have to move the 6 first. So we're going to subtract 6 from both sides, and we get the log base 3 of 2x equals 4. And then when I rewrite this, I want to try to preserve the side of the equal sign that the of part of the log is on. So I'm going to keep the 2x on this side of the equal sign, and my base of my log is the base of my exponent, and then my exponent becomes, or what's equal to the log becomes the exponent. So I get 2x equals 3 to the 4th power. That's 2x equals 81 divided by 2, and x is 40.5 or 81 halves. And then I go back and I say, okay, if I plug that in, is it positive? And the answer is yes, so I don't have to worry about it being extraneous. On the second problem, log base 10, remember when it's not written there, it's base 10, x minus 3 equals negative 2. So again, we want to preserve the of part of the log, so x minus 3 is going to stay on this side of the equal sign, and then the base of my log, which is that invisible 10, is the base of my exponent, and my exponent is the number that the log is equal to. So I have x minus 3 equals 10 to the negative 2 power. And x minus 3 equals 1 over 100. And add my 3. So x equals 3 and 1/100th, or 301 over 100. Or 3.01. So any of those would be acceptable answers. In this equation, we first, before we can rewrite it, have to deal with the 3 out front. So we're going to divide by that first. And I get the ln of 2x plus 1 equals 4. And then again, we're going to preserve the side of the equal sign the of part is on. So 2x plus 1 equals, what is the ln? Log base e. So there's my base e, and to the exponent, which is what the log equals, the 4. So I have 2x plus 1 equals e to the 4th. Subtract 1. 2x equals e to the 4th minus 1. Divide by 2. X is e to the 4th minus 1 divided by 2, and you can plug that in your calculator. E to the 4th, e is the second ln button, and then subtract 1 minus 2. You can get a decimal approximation from there.